A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear brothers and sisters in Islam, Assalamu alaikum wa rahmatullahi wa barakatuh. My today's video topic is the derivation of the planetary equation or the elliptical orbits of the planets or the projectiles. Okay, let's start from uh, in continuation uh, with my previous videos, the derivation that I've already done. Okay, so the centrifugal velocity let us equate the centrifugal velocity with the centripetal velocity. I mean the centrifugal acceleration with the centripetal acceleration. Okay, so let us rewrite the above equation. Is equal to v square cos square beta over r. Okay, so we have two more equations, dr over dt, that I have already derived in my previous videos. You can watch those videos. Dr over dt is equal to v sine beta, and h is equal to rv cos beta. Okay, so let's put the value of dr over dt in the above equation, which we can write as v square cos square beta over r. And the other equation is d over dt rv cos beta. So we have one equation and the other equation. So we have two equations. We will solve these equations to get the answer. From equation 2, we have 0 is equal to minus rv sine d beta over dt plus r cos beta dv over dt plus v cos beta dr over dt and from equation 1 we have v cos beta d beta over dt plus sine beta dv over dt minus v square cos square beta over r is equal to minus gm over r square. Now solving the two equations, above for dv and d beta over dt, we obtain as below. Dv over dt is equal to minus gm over r square sine beta. And beta over dt is equal to minus gm over r square cos beta over v plus v cos beta over r. We can also write d beta over dt as v over r minus 1 over v gm over r square cos beta. Or simply dv over dt is equal to minus gm over r square sin beta, and d beta over dt is equal to v over r minus 1 over v gm r square cos beta. Allahumma hasibna hisaban yasira. Natural laws remained hid from sight. Allah Kareem wished. Let Tahir be. And all was light. Okay, let's go to page 30 of my book. Okay, so we'll use the previous equation. dv over dt is equal to minus r square sin beta. This equation is an extremely important equation in gravity, which is an offshoot of basically relativity. Okay, in my book Natural Theory of Relativity, Inertia, Gravitation and Gravity, I have done the following derivation in 5 different ways which eyes have not yet seen, but I will choose the one that eyes have already seen a little bit before. The rest of the 4 that are completely different, they are given in my book. Okay, so let's do it by the simplest and the easiest and the well-known method of applying the chain rule on the above equation. dv over dr over dt is equal to minus gm r square sin beta. dv over dr and dr over dt is v sin beta is equal to minus gm over r square sin beta. So we have v dv is equal to minus gm over r square dr. Integrating, we have V dV R2 minus Gm over R square dr. So we have V2 square over 2 minus V1 square over 2 is equal to Gm 1 over R2 minus 1 over R1. Okay, now let's go to page 56 of my book. Okay, so I'm just writing it down from my book. Subhanallah wa bihamdihi, Subhanallahil azim wa bihamdihi, astaghfirullah. Okay, so dr over dt is equal to V sine beta Tahir's partial field equation. One dpfe dash 1 and r d theta over dt. I have proven these equations in my previous videos. R d theta or rt is equal to V cos beta is Tahir's partial field equation 2. The above is not partial in the sense of partial differential equations. It just means pieces, parts of a bigger thing. Bismillah ar-Rahman ar-Rahim. Kul huwallahu ahad, Allahu samad, lam yalid walam yulad walam yakul lahu kufuwan ahad. Now here is the deal. Dividing PP FE dash 1 by the TP FE dash 2 for the first time in the Islamic history, world history. In the last 1000 years. I get the Tahir field equation as below. dr over r d theta is equal to tan beta. We can get d theta from here is equal to dr over r tan beta. So this is Tahir field equation. Constant of integration is intentionally chosen to be equal to the weight of current relativistic theories. When we solve the integral, which is called Tahir integral in gravitation, we will see that the choice was correct. Now let Tahir do the barbecue of the above Tahir field equation. As below. Theta is equal to integrate dr over r tan beta, which is further equal to dr over r secant square beta minus 1. Integrate dr over r square v square over h square minus 1, where h is equal to rv cos beta. this equal to integrate h dr over r square v square minus h square. Let us represent 1 over r is equal to by u. Therefore, we have u is equal to 1 over r, and du is equal to minus dr over r square, or du over u is equal to minus dr over r. So theta becomes h dr r square v square minus h square is equal to minus h du over u v square over u square minus h square is equal to minus h du over v square minus h square u square. So theta is equal to minus h du over v square minus h square u square is equal to minus h du over au square plus bu plus c. Now, as has gone above, we have v square minus v square r is equal to 2 gm 1 over r minus 1 over r. V square is equal to v square r plus 2 gm putting the above value into the integral, we obtain for non-gravitivistic results of static orbits of planets, projectiles, etc. The following integral. Theta is equal to minus h du v square minus h square u square is equal to minus h du over v square r plus 2 gm 1 over r minus 1 over r minus h square u square. Theta is equal to minus h du divided by v square r plus 2 gm u minus 1 over r minus h square u square is equal to minus h du. H is a constant of inertia and it is also a constant of gravitation. Minus h du, because gravitation goes along with inertia, so the inertial part must be retained. So minus h du over v square r minus 2 gm over r plus 2 gm u minus h square u square. Now we have integrate du over au square plus bu plus c is equal to minus 1 square root of minus a arc sine 2au plus b divided by minus delta where a less than 0 and delta less than 0, where delta is equal to 4ac minus b square. So we obtain theta is equal to h over minus a arc sine 2au plus b over square root of minus delta. For our case, we have a is equal to minus h square, b is equal to 2 gm, and c is equal to v square r minus 2 gm over r. Theta is equal to integrate h du over v square minus h square u square is equal to minus h du over square root of au square plus bu plus c. Inserting the values I obtain as below. Theta is equal to minus h multiplied by minus 1 over h square, square root of h square, arc sine minus 2 h square u plus 2 gm over 2 gm whole square plus 4 h square v square r minus 2 gm over r square root. Sine theta is equal to minus 2h square u plus 2 gm over 4 g square m square plus 4 h square v square r minus 2 gm over r square root. Okay, sine theta is equal to minus 2h square u plus 2 gm over 2h g square m square over h square plus v square over r minus 2 gm over r square root. Sine theta is equal to minus h u plus gm over h divided by g square m square over h square plus v square r minus 2 gm over r. G square m square over h square v square r minus 2 gm over r sine theta is equal to minus h u plus gm over h. Hu is equal to gm over h minus g square m square over h square plus v square r minus 2 gm over r sine theta. H over r is equal to gm over h minus g square m square over h square v square r minus 2 gm over r sine theta. So r is equal to h over gm over h minus g square m square over h square plus v square r minus 2 gm over r sine theta. Further simplifying, we get gm over h 1 minus h over gm g square m square over h square plus v square over r minus 2gm over r sine theta. Further simplifying, r is equal to h square over gm divided by 1 minus 1 plus h square over g square m square v square r minus 2 gm over r sine theta. R is equal to h square over gm divided by 1 minus epsilon sine theta is equal to the eccentricity of the elliptical orbit 1 plus h square over g square m square v square r minus 2 gm over r is the eccentricity of the non-relativistic orbit of planets, projectiles. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم إنك حميد مجيد. For gravitivistic calculations of the same approximate elliptical orbits of the planets and projectiles, please wait for my incoming videos. Thanks for watching.